Okay, so this is F-5 Part B. And, um, okay, so what we're about to learn is something called U substitution. And U substitution, well, we already actually used that for derivatives, but you could also use it for antiderivatives or integrals. So basically, guys, when you're evaluating an integral, this is a nice order of things to try. All right, so first, is it a one step? If it's not, you could try some algebra to rewrite it so it is. But then if the algebra doesn't work, you could look for f of u. Okay, so f of u would be if you had one function inside of another function. Okay, so that would be finding an f of u. And it doesn't have, the whole thing doesn't have to be of the form f of u, but just within the expression itself, if you find an f of u, that is helpful. You would let u equal whatever you found as the inside. Alrighty, and then if you can't find a good u, then you would let u equal the entire denominator. That's going to happen a few examples from now. Okay, but let me just go through this. So, we're going to have to use the fundamental theorem of calculus. Okay, so we're going to have to do bracket, endpoints on the end of the bracket, and the antiderivative goes inside. And then we do final value minus initial value. All right, so that's what we've got to do. But this is not a one step, okay? Is there any algebra that we could do? Like, is there anything we could expand or, simplify in any way? Answer is no. So now we look for f of u. Okay, so looking for f of u, you're looking for one function that is inside of another, and I see it actually right there. Okay, so that right there, that would be your f of u that you found. Okay, so once you find the f of u, if there is one, you write down to yourself what the u is. So u equals 4 minus 3x squared. Okay. Now, we're doing antiderivatives, but same with derivatives. After you find the u, immediately take its derivative in Leibniz notation. Okay. So du dx equals negative 6x. Okay. Now, let's go back up to this problem. Just like doing a u substitution for derivatives, the same with antiderivatives, the point is to, instead of the variable being x, you're going to change the variable to u. Okay, so what needs to change? So this binomial is going to change to a u. All right, I already wrote that down. But then also, guys, the dx is going to have to change to a du. And these values right now are x values. They are going to have to change to u values. Okay, so let's do the endpoints first. So negative 2 is an x value. I want to change it to a u value, and u is this. So if I take negative 2 and plug it in for the x, here I get positive 4. So I'm getting 4 minus 3 times 4, which is 12. Okay, so that's going to be 7. Or sorry, 8, negative 8. Okay, and then I plug the 1 in here, and I get 4 minus 3. So this is, oh, it's actually still going to be 1. 4 minus 3. All right. Now, how am I going to replace the dx? You're going to solve for dx right here. Okay. So, what I can do is I can multiply both sides by dx. And then I divide both sides by negative 6x. So dx equals du over negative 6x. So I'll cross that dx out. This is going to be du over negative 6x. Okay, so now let me rewrite this. So I'll bracket that off. So I have the integral from 4 minus 12 is negative 8. From negative 8 to 1. Right, and then this is du over negative 6x. So I've got 10x u to the 2/3 over 3. Okay, now guys, you will know that you chose the right or the correct u If all of the x's cancel and u is the only variable that you have. So this is just like multiplication here. So the negative 6x, I can put inside instead. Do the x's cancel? Absolutely, and you want that to happen. Now we've got a coefficient, we've got 10 over negative 18, so I'll take that out front. So negative 10 over 18. Okay, and then you just keep asking yourself this question, is this a one step? So now we change the variable to u, and is this a one step? Yes, it is. So now let me simplify this fraction. So this is negative 5/9. So I am ready now to take the antiderivative, and I'm using it to do the fundamental theorem of calculus. Okay, so that's a 1. So we've got 1u to the 5/3, because you're adding 1 to the exponent, and then you divide it by 5/3. Okay, let me move up here. So negative 5/9. I'm just going to write this nicer. So that's 3/5 u to the 5/3. Okay. So this is up here the final time. This down here is the initial time. If you plug in the final time, you're going to get the final value. If you plug in the initial time, you're going to get the initial value. And I know time can't be negative. I'm just using it as an analogy. So this is net change. This is the fundamental theorem of calculus. So I have negative 5/9. Right now, this bracket is just going to expand because it's going to be like a binomial now. So this is 3/5, 1 to the 5/3, minus 3/5, negative 8 to the 5/3. Okay, and leading up to the AP test, guys, there's going to be a non-calculator section, and you're going to have to be able to do this type of arithmetic. And you could do arithmetic with using algebra concepts. So for example, this is 2 terms. I could take out a 3/5. So this is negative 5/9 times 3/5. And then I've got 1 to the 5/3 minus negative 8 to the 5/3. Okay, now how am I going to evaluate these things? It's easier for me to use radical form instead of a fractional exponent. All right, so back over here, let me do some simplifying. All right, so those 5s are canceling, the 3 is a 1, and then the 9 is a 3. All right, so I'm carrying down here negative 1/3. And I've got the cubed root of 1 to the 5th. All right, guys, the exponent, it could be outside of the radical or it could be underneath the radical, either. If you're evaluating a number, it's easier to have it outside because the number will get smaller. All right, anyway, so minus the cubed root of negative 8 to the 5th. Okay, negative 1/3. The cubed root of 1 is 1, to the 5th is still 1, minus the cubed root of negative 8 is negative 2, and then that's to the 5th. Negative 1/3, 1 minus, that's negative 32. Negative 1/3, 1 plus 32. Negative 1/3 times 33. Okay. And then, so the answer is negative 11. Okay. And guys, if you really want to blow your mind, go to your calculator, do math 9 on the original, and you will get negative 11. It's going to be negative 11.000 something because the calculator for some reason won't give you this exactly. But yeah, you'll see it. Okay, now the second one. So this one is going to be faster because this is not a definite integral. It is an indefinite integral, so we're doing bracket plus c. So with bracket plus c, the antiderivative goes in the bracket. And this, so we're going back to this way of thinking. Is this a one step? No way. Is there any algebra that I could do? Well, yeah, I mean, I could expand that, but that's going to be really messy. I'll have 4 binomials multiplying. That's too much. And I don't think it's going to help anyway. It would just give us a much bigger denominator. Look for f of u. Look for f of u. I see it. Okay, it's this. All right, so that right there is f of u. So what is u? So u would be 2x squared minus 3. You immediately do the derivative. Okay. Alrighty, guys. Now I look back up at the top. I don't have to change any endpoints, but this dx I do have to change. So I go down here and I solve for dx. I multiply both sides by dx, but then I divide both sides by 4x. I'm going to do that in one move. So I get du over 4x. So that's what this is, du over 4x. All right, guys, you know that you chose the correct u if the x's cancel. So I have 24x, and then in the bottom, u to the 4th. Okay. Guys, this is multiplication in the bottom here, so I could just put 4x. The x's are canceling, so yes, we got the right u. 24 over 4, that's 6. So I'll just take 6 out front. Now I'm going to do the antiderivative, so if I had ax to the n or au to the n in this case, that would be extremely helpful. So anyway, u to the negative 4. Is that a one step? Yes. The 6 carries down. I replace all the integral notation with a bracket plus c. 1 u to the negative 3rd divided by negative 3. Okay. So guys, what I've got, by the way, this is going to be like a 6 on top and a negative 3 on the bottom. So that's negative 2 u to the negative 3rd plus c. Now, something you have to do for these indefinite integrals is that you have to plug the u back in. So this is negative 2x squared minus 3 to the 4th plus c. And that is the answer.